Hello, this is part 4 of getting started with ka9q radio, and in this portion we'll look at a wideband spectral display capability that's been recently added to the various software packages. The configuration is very similar to that of the previous packages in that we have a server using a Raspberry Pi or other Linux computer. It has an RX-888 receiver, dongle plugged into a USB port, and a HF antenna. We access it using SSH over Ethernet, and it's running ka9q radio. The client configuration is a little bit different in this package. We'll be running a client computer with Linux, and on that client computer we'll have ka9q radio, a new package, ka9q web, written by Franco Venturi, and some support packages for a web server, Onion, and some related libraries. And then we'll be running a browser on the Linux computer to visualize the wideband spectral display. And again, we'll have an Ethernet switch in between these two computers. This is a block diagram, same slide as previous videos. The server is running ka9q radio and has a receiver. The Linux PC is a client, and it will be running ka9q radio, ka9q web, and a HTTP package and a web browser. The software sources ka9q radio comes from Phil Karn's GitHub page. ka9q web comes from Franco Venturi's web page. And the Onion web library comes from David Maroney's Onion package. In addition, we'll need some support libraries for Onion, libgnu TLS 28-dev and libgcrypt-dev. We found that these libraries sometimes vary a little bit from various Linux distributions. libgnu TLS devs on some, but it's lib28 on others. gcrypt on Ubuntu 22.04, but libgcrypt 20 on some others. So you may have to experiment a little bit on your package. Setup is needed for ka9q web. So if you git clone the ka9q web package from Franco Venturi's GitHub, there'll be a file in their readme.md which has complete details on the setup. Basically, we'll install the Onion dependencies on the client. We'll install Onion on the client, which will involve going through cmake, make install, and ldconfig. We'll install ka9q-web on the client, make install. And then we'll copy the radio D at rx888-web.conf file from the ka9q web/config directory over to the server into the ka9q-radio directory on the server. And then we'll edit it, and we'll change TTL from 0 to a value of 1 to allow one hop over the local network. To run ka9q web on the server, we'll run radio D at rx888-web.conf. On the client, we'll change to the ka9q-web directory and then run in that directory the ka9q-web executable program. And we'll leave the console window open to collect error messages. And then finally on the client, we'll open a browser and we'll navigate to http://localhost:8081, which will allow us to visualize the wideband spectral display. This is a snapshot of the config file on the server, and you can see we've edited it to change TTL to be a value of 1. All the rest of the lines in the configuration file are the same. We'll now have a demonstration of bringing up the spectrum display. So the first thing that we'll do is SSH into the server. We'll change to the ka9q radio directory, and we'll run the radio script rx888-web.conf. We'll now minimize that window, and we'll bring up another window. And here on the client, what we'll do is to change to the ka9q web directory. And we will run the executable program ka9q-web, which we built as part of the web installation process. Now we'll go to a web browser, and we'll open up a connection to our local host. And here we can see the wideband spectral display from the radio. There's a few artifacts, and this is pretty new software, so I'd expect a few things to change over the course of the next few weeks or month or two. There's a few strong carriers here up in the 24 megahertz range, and I don't know how real all of those particular carriers are. We can see the very low frequency spectrum off to the left, and then we can see the AM broadcast band and some other things as we go down. So that's it for this demonstration. We can select some of the frequencies here for the center line display, the red line, and we can set the frequencies, and you can play with those on your own. And finally, I'd like to acknowledge a lot of very helpful folks. John Melton, G0ORX, has written the C code to allow visualizing the spectra in integration with the Onion libraries. Franco Venturi has forked that code and adapted it to ka9q-web. And of course, this is all part of the Ham Radio Citizen Science Project, and Dr. Nathaniel Frizzell, W2 NAF, who's the project principal investigator.